A man is paid $200,000 a week to kick a ball into a net the size of a small garage, from 12 yards away, with nobody allowed to touch him. And he misses. On purpose, sort of. Because the math says he has to. Here's the part that'll bother you. That miss wasn't a mistake. It was a sophisticated, mathematically optimal decision executed by a man who has never read a game theory textbook in his life. Penalty shootouts look like chaos, a coin flip in shorts. They are not. They are a solved problem. And the solution is one of the most beautiful ideas in all of mathematics, hiding inside the most stressful 30 seconds in sports. So let's solve soccer. Start with the situation, because it's almost suspiciously perfect for math. A penalty kick has two players, the kicker and the goalkeeper. They make their decisions essentially at the same time. There's no chatting it out. I've never seen a keeper lean over and say so. Left? The kicker picks a direction. The keeper picks a direction. And here's the crucial bit. The ball travels so fast that the keeper has about 4/10 of a second to react. That is not enough time to see where the ball is going and then move. So the keeper has to commit early, basically guessing, while the kicker is also committing early. Two players, simultaneous choices, no communication, fixed outcomes. If you've ever taken an economics class, alarm bells are going off. This is a textbook two-player simultaneous zero-sum game. It's rock, paper, scissors with national pride and a crying goalkeeper. Now, your instinct, and the instinct of every guy yelling at the television, is just pick a corner and smash it. Great. Let's say you always go left. You've got a cannon of a left-footed shot. You go left every single time. What happens? The keeper figures it out by about the third one. Now the keeper dives left every time, and your beautiful cannon goes straight into his face. Congratulations. You've been solved. Okay, you say, fine, I'll switch to the right. Brilliant. Now the keeper notices that, and dives right. And around you go forever. Two grown men locked in an eternal dance of trying to outguess each other. In game theory we call any always do the same thing approach a pure strategy. And the lesson of the penalty kick is that every pure strategy can be exploited. Always left gets red. Always right gets red. Predictability is death. Which is exactly why penalty shootouts feel random. They feel random because being random is the optimal strategy. Hold that thought, because it's the whole video. Let's build the actual math, and to do that we need a payoff matrix. Don't panic, it's a grid. The kicker has three options: shoot left, shoot center, shoot right. The keeper has three options: dive left, stay center, dive right. For each combination, we fill in the probability that the kicker scores. And we don't have to make these numbers up, because economists, bless them, they will study anything, went and analyzed thousands of real professional penalties. Here's roughly what the data says. Kicker goes left, keeper guesses wrong and dives right. The kicker scores about 95% of the time. Easy. Kicker goes left, keeper guesses correctly and dives left. Now it drops to around 58%, because the keeper might actually save it. Same story on the right side, just mirrored. And the center? Kicker shoots straight down the middle and the keeper dives out of the way. A whopping 81% scoring rate. But if the keeper just stands there, which keepers hate doing, it looks lazy. The center shot drops to about 44%. Color this grid in. Green where the kicker scores a lot, red where they don't, and a pattern jumps out. The diagonal, where the keeper guesses correctly, is reddish, lower scoring. The off-diagonal, where the keeper guesses wrong, is gloriously green. Which makes total sense. The keeper's entire job is to guess right. The kicker's entire job is to be wherever the keeper isn't. So how do you both play this optimally? Enter John Nash. Yes, the beautiful mind guy, the one Russell Crowe played while staring intensely at windows. Nash gave us a concept called the Nash equilibrium, and it's deceptively simple. It's a situation where neither player can improve their outcome by changing their own strategy alone, given what the other player is doing. It's a stalemate of self-interest. Everybody's doing the best they can, given everybody else. Now here's the twist that makes the penalty kick so gorgeous. In this game, there's no single best choice. The Nash equilibrium isn't always go left. It's a mixed strategy. You randomize, but with very specific probabilities. And the magic condition is this: the kicker has to pick his probabilities so that the keeper is perfectly indifferent between diving left and diving right. Same expected outcome either way. And the keeper has to do the exact same thing back. Make the kicker indifferent between his options. Why indifferent? Because if the keeper has any reason to prefer one side, if he can predict you even 5% better than a coin flip, he will lean that way and exploit you. The only way to take away his edge is to make both of his choices equally bad. You don't beat the keeper by outguessing him. You beat him by being genuinely unguessable. When you crank through the equations, and we will spare you the algebra, this is a happy place. The professional data says the optimal kicker shoots roughly 38% left, 38% right, and about 17% center. The keeper dives roughly 42% left, 42% right, and stays central about 16% of the time. Run that, and the kicker scores around 75 to 80% of the time, which, if you check World Cup history, is exactly the long-run conversion rate. The math isn't describing some fantasy. It's describing what actually happens. But here's the genuinely shocking part. Remember, the center shot scores 81% when the keeper dives. That's the single best individual option on the entire board. So why do pros only do it 17% of the time? Why aren't they shooting down the middle constantly? Because the equilibrium self-corrects. If kickers started shooting center more often, keepers would simply stop diving and start standing still. And the moment they do, your center shot collapses from 81% all the way down to 44%. The high payoff exists precisely because nobody overuses it. The strategy is rare on purpose. It's the mathematical equivalent of a restaurant that's only good because it's hard to get into. And now the question you're actually asking, do real players know any of this? Do they have John Nash whispering in their earpiece? No. They've never seen The Matrix. And yet, this is the beautiful part. They play it almost perfectly anyway. In 2003, an economist named Ignazio Palacios Huerta published a paper with the magnificently smug title Professionals Play Minimax. He took years of real professional penalty data and tested it against the Nash predictions. The actual shot distributions matched the theory within statistical noise. He even ran a serial independence test, checking whether each penalty was independent of the last one, or whether players fell into patterns, like going left, right. Truly random sequences shouldn't have patterns. The pros passed. Their choices were statistically indistinguishable from a random number generator wearing cleats. They evolved this. Through thousands of repetitions, coaching intuition, and the brutal feedback of getting their shots saved on live television, professional players converged on the exact strategy a mathematician would prescribe. They're running the Nash formation without ever learning the playbook. Here's a fun gut punch. Amateurs don't do this. Recreational players show clear, exploitable patterns. So the next time you lose a pickup game on penalties, take comfort. You weren't unlucky, you were just statistically legible. Now, about that center shot. There's one wrinkle the pure math doesn't capture, and it's deeply, painfully human. The equilibrium says shoot center about 17% of the time. In reality, pros do it slightly less than they mathematically should. Why? Because of shame. Think about it. If you shoot to the corner and the keeper happens to guess right and saves it, you shrug. Tough luck. The crowd sighs sympathetically. But if you shoot straight down the middle and the keeper just stands there and catches it like he's receiving a gift, you look like a complete fool. Same result. The ball didn't go in either way. But the humiliation is wildly different. Economists call this Minimax Regret, and what it means is that the best mathematical option is also the one that makes you look the stupidest when it fails. Players quietly weight that embarrassment beyond the payoff, and it shifts the real equilibrium a hair away from the theory. So when a commentator screams he should have gone the other way, no. The whole point is that you cannot know which way. If the commentator could predict it, so could the keeper, and then it wouldn't work. The strategy is unpredictable by design. Insight is a coward. And this is why the penalty kick matters far beyond soccer. It's a tiny, perfect window into how the entire competitive world works. Poker? You have to bluff sometimes. A player who only bets on great hands is an open book. Military strategy? Unpredictability literally is the strategy. Pricing wars, auctions, even evolutionary biology. Animals randomizing their behavior to avoid being preyed upon by pattern readers. It's the same math, the same equilibrium, over and over. There's an echo here of something we explored in our video on compound interest, how tiny differences compound into enormous gaps over time. A keeper who's just 5% better at reading you doesn't gain a little. Over a tournament, that edge compounds into the difference between a hero and a guy on a flight home. Small predictability, exponential consequences. So let's recap. A penalty kick is a two-player, simultaneous, zero-sum game. Any predictable strategy gets exploited, which is why the optimal play requires genuine randomness. The Nash equilibrium is a mixed strategy where each player makes the other indifferent, roughly 38% to each corner, 17% down the middle. Real professionals nail this without knowing the math, because thousands of repetitions sanded them into the optimal shape. And the best individual option, the center shot, stays rare precisely because overusing it would destroy it, with a little extra human flinch because nobody wants to look like an idiot on television. So the next time you watch a shootout and your friend says it's all just luck, you can lean back and explain that you are in fact watching extremely sophisticated, mathematically optimal rock-paper-scissors performed by millionaires under unbearable pressure. They will love that. You will not be invited back. If you enjoyed this, Subscribe to Improper Integral for more visual math and science, and share it with the one friend who screams at the TV. We'll see you in the next one.